This is the NukAlert. It is a tiny product that can even fit on your keychain, and will warn you when you are in the presence of dangerous levels of radiation. Well, at least that is what it's claimed to be able to do. This is a bit of a spoiler, but we have a lot of doubts about the usefulness of this product. In fact, I would go so far as to say that it is easily the worst product we have ever reviewed on this channel. Frankly, it is a piece of crap. With a price tag of $180, it is also a pretty expensive, steaming piece of feces. To be fair to this product, it does have a very unconventional method of operation, so it is unique in its own little way. So, let's just take a look at how the NukAlert works, and also how it is supposed to be used. Clearly, this product is being targeted at the so-called prepper market. First of all, let me just say that we have nothing against preppers. Whilst researching this video, we have delved into some parts of the prepper world, and interacted with more than a few, very interesting characters. In general, there is nothing wrong with taking out some apocalypse insurance. And, who doesn't like the idea of being self-sufficient? Yes, I know. In some dark corners, there can be some politics, and in places, a little ranting and conspiracy. Mostly, this is confined to those that seek to weaponize paranoia, for the purposes of selling products. Products, just like the NukAlert. But as a whole, we found the prepper movement to be a welcoming, and diverse bunch of people, who have a pretty fascinating hobby. And, it is a hobby that involves learning and sharing positive ideas. And in my opinion, that is never a bad thing. Personally, I think this product is totally useless for a prepper. There are far better detectors available, and for a lot lower cost than this shitty thing. So, let's just touch on what this device actually does, and how it is supposed to be used. The NukAlert is a sealed product that has a claimed battery life of 10 years, and it doesn't have a display or any buttons. The device communicates by a series of small clicks and occasionally a chirping bird sound. All of which are very quiet. Conveniently, it does have a table printed on the back, that allows the user to calculate just how long they can expect to live at the current dose rate, based upon the number of clicks this thing emits. It sounds so terribly useful, doesn't it? So, the basic idea is that you walk around with this thing on your keyring, or on your bag, and it will warn you when a nuclear bomb has gone off nearby, with a pleasant little chirping sound. Are they fucking serious? So, just in case you missed the blinding flash, the 500-meter fireball, the supersonic blast wave, and a 20-mile tall mushroom cloud, you have this cute little thing chirping at you. Well, that was $180 well spent. You see, the problem is that this product is not very sensitive. The NukAlert claims to be able to detect dose rates that are above 2 millisieverts per hour. For the little NukAlert to be triggered by the immediate radiation release, you would need to be within about 10 miles of ground zero. Which would put you around here. But what about the fallout? Perhaps this device is useful for protecting you from that deadly shower of radioactive fission products. Well, don't count on it, this thing is equally shit when it comes to that job too. If we look at the major fission products that exist in the fallout from a nuclear explosion, first of all, we can remove those that decay with only an alpha or beta release. The NukAlert cannot detect these, nor does it claim to be able to do so. Now, if we remove those that are unlikely to be absorbed by the human body, and also those with short half-lives, we are only left with one fallout product that it might be able to usefully detect. cesium-137. But just to show how terrible this product is when it comes to detection sensitivity, consider this example. You probably remember this shit show, in Western Australia, in 2023, over a lost capsule of cesium-137. Well, the NukAlert would need to be within less than 1 meter of that capsule of death, to be able to detect anything. Whereas this cheap Chinese Geiger counter, would be able to detect elevated levels of radiation, at over 30 meters of distance. Come the apocalypse, I'd rather have a cheapo Geiger counter, rather than this shitty NukAlert. The only way to test this little thing, is to capture the sound from the piezo sounder, using a microphone. We are using a USB instrumentation microphone. This isn't the most sensitive or the lowest noise one we have, but being USB based, it doesn't require a whole rack of equipment to be able to work. Obviously, we are using science grade blue tack for this job. The first test source we are going to use today is thorium-232. This is a fragment taken from a so-called negative ion pendant. With this gamma ray spectrometer, we get a gamma dose rate of about 1 microsievert per hour, which is about 10 times the normal background level. We are not actually expecting this horrid little thing to be able to detect anything in this test. It would require this source to be at least 2,000 times stronger for there to be any chance of that. But we do enjoy getting out our test sources and doing a little experimentation. Okay, let's try a little cesium-137, perhaps a stronger gamma source will be able to trigger this thing into action. This sample has an activity level that is about 20 times the background. I'm sure the viewers are holding their breath right now, wondering if the little NukAlert will be able to detect this. Well, of course it didn't. Nobody in their right mind was expecting it to. So, let's just rush through the rest of our test sources, and just confirm that it is basically impossible to test this product with anything short of a direct nuclear strike. This is our favorite sample of uranium ore. It has an activity of about 250 times background level. But it will come as no surprise that it doesn't even move the needle on the bloody NukAlert. Say hello to americium-241. This radioisotope is actually quite deadly if ingested or inhaled. But for some reason, about 80% of us have this inside smoke alarms in our homes. And that is despite the fact that this type of ionization smoke alarm has been proven to be pretty ineffective against normal home fires. I just wonder if it is easier for the nuclear power industry to give this shit away, rather than figuring out how to safely store it, for a few thousand years. This is radium-226. A particularly nasty isotope, that was discovered by Madame Curie. And was responsible for her untimely and sad death. But, just like all of the previous tests, this one also generated absolutely zero response from the fucking NukAlert. So, there is nothing else to do but to break out the strontium-90. Well, actually, strontium-90 is a beta emitter and as such is not detectable by the NukAlert. But, this is my strongest radioisotope test source, so it's time for our weapon of last resort. I am going to have to blast this thing with some homemade X-rays. This is a soft X-ray source, and is being used in cold cathode mode, which limits the X-ray output. As you can see, it generates a very strong reaction from this radiocode detector. But of course, the NukAlert did absolutely bugger all, even when right next to the X-ray source. So, I figured I would just crank up the power, and hope for the best. Which didn't exactly go according to plan. We are going to have to think of something else. So, after searching online for a video of the NukAlert in operation, I found this rather grainy video of the inventor performing a basic test of this device. He appears to be using a dental X-ray machine, which probably has an applied voltage of about 60 kV. And now he is going to blast this thing with a fairly high dose X-ray source. Let's see the reaction. Okay, it looks like I am going to have to spend some more money just to test this horrid thing. In a dark corner of the internet, I found this. It's a more powerful version of the soft X-ray source that I recently destroyed. This one appears to have about 100 times the X-ray flux of our old unit. And with this one, there is no need for an external high voltage power supply. It seems to have been hacked to use the internal supply. Just apply 12 volts, and we have some X-rays to test with. So, let's just test this new X-ray source with some of the detectors we have collected. After spending all this bloody money, we want to maximize the value we can get from this source. At this close range, almost all of the detectors that we have are maxed out in this test. That is actually not a terrible thing, so long as they continue to show that the radiation is at the limit, then that is a safe condition. It is good that we now have a source that can demonstrate the limits when we test detectors in the future. There are probably some other cool experiments that can be done with this too. However, not all of our detectors were maxed out. This RAM1 dosimeter and the HFS-10 didn't even notice the X-ray source when it is energized. The photons need to be at a much higher energy level for these shitty products to register anything. So, I tested this X-ray source with a couple of gamma-ray spectrometers that I own. The results didn't really agree with my current understanding of how X-ray tubes work, so I am going to dig deeper and report back in a subsequent video. But, at least they did better than the piece of shit Gamma Scout. This thing, in intense radiation conditions, will lose its fucking mind and start reporting low dose rates. What a reassuring feature that is. So, now for the moment of truth. Are we able to trigger this device using our new X-ray source? We have changed over to using a standalone audio recorder. You will see just why we did that in a moment. Okay, it's time to blast this thing with some X-rays. It took a lot to get here, but we have finally triggered the NukAlert. And now, the bloody thing won't shut up. In fact, it just kept going, and going, and going. Even after the rest of the experiment had been tidied away, it just continued to chirp. We waited for 10 minutes, and then we waited for an hour. But the stupid thing just kept chirping. So, we left it for the weekend, and finally, it stopped that irritating sound. But even after that time, the device was still clicking faster than it originally had. Well, it's time to cut this horrid little thing open and see what is inside it. This could well be the shortest teardown in the history of this channel. You see, there is almost nothing inside of this horrid little thing. This is the so-called scintillation module. I guess the nicest thing to say about it is that it is unique. Nobody else is using this technique. Mind you, there is a bloody good reason for that. We will discuss this thing in more detail later. This is the MCU at the heart of the product. It is an 8-bit PIC, with the very bare minimum of features. This green LED is used to improve the sensitivity of the scintillation module. It periodically flashes, in a crude attempt to improve the sensitivity of the radiation detection. Actually, all it is really doing is fooling the user that those little clicks means that it is busy working. This is the permanently installed battery. As coin cells go, this one is an absolute monster, and probably the most expensive component in the product. And then, there are two resistors and a capacitor. I am only mentioning these because there is basically nothing else left to discuss. So there you have it. A PCB with just 7 components on it, and this horrid piece of shit can be yours for just $180. Ooh, what a bargain. So, let's talk about that scintillation module. The design of this was covered by a patent that recently expired, though I doubt if anyone is wanting to copy this. According to the patent, and also to the technical description given in the documentation that comes with the product, the scintillation phosphor is a compound called gadolinium oxysulfide. This compound was used in phosphor screens that were used in old-school photographic X-ray images. Gadolinium oxysulfide will fluoresce with a faint green glow when exposed to X-rays. This compound has been bonded to the inside of a plastic cone, and a light sensor has been added to the bottom of the package to detect the faint glow. And for that light sensor, the designer has used a cadmium sulfide, light-dependent resistor. This is easily the cheapest electronic light sensing component that it is possible to buy. So, sounds like an interesting design concept, doesn't it? Well, ignoring the little stuff, there are two glaring issues with this detection technique. Normally, scintillation crystals are used with very sensitive light detectors that are capable of detecting single photons. Detectors like silicon photomultipliers. And this thing uses a horrible light-dependent resistor, something at the wrong end of the technology spectrum. The end of the spectrum that is called cheap and nasty. Compared to what is normally used in a scintillation detector, this is like comparing a light bulb to a laser beam. The other major issue is with the scintillation material itself. Gadolinium oxysulfide is quite sensitive to X-rays, but for gamma rays, it has a terrible response. Comparing the sensitivity of the soft X-rays we used to trigger the device to gamma rays emitted by an isotope like cesium-137. Gadolinium oxysulfide is about 3,000 times less sensitive to gamma rays. Put simply, this means that the NukAlert is great for telling you that your dentist's X-ray machine is working, but almost totally useless for its actual intended purpose. Following the tragedy of 9/11, there was a strong climate of fear, uncertainty, and paranoia. Not just in the US, but across the world at large. The manufacturers of radiological detection equipment suddenly had a huge demand for their products, both for emergency responders and for the general public. What was needed was a small, portable, easy to use, and low-cost product. This was when the NukAlert appeared on the market. But the major players in this market had a problem. Their own products were basically scientific instruments. So whilst they scrabbled to develop their own more suitable devices, on the sales side, some mistakes were made. Mistakes, like when BNC, a famous manufacturer of high-quality radiation detection equipment, decided to sell the bloody NukAlert. Clearly, this created a lot of credibility for this horrible device. But, as manufacturers developed their own products, the NukAlert was quietly dropped. Interestingly, BNC's own product was called the NukAlert, with an E. All of this new generation of products ended up being targeted at government agencies, so once again, were too expensive for the general public. So, once again, we are left with no realistic, like-for-like alternatives to the NukAlert. Please, if you know of any, do let everyone know in the comments. Right, let's see if we can make a detector that is better than the damn NukAlert out of this old tin. There are many of these ionization chamber projects on YouTube. What many of those videos forget to mention is that all tins created for foodstuffs have a protective coating, usually a very thin polymer. This coating must be removed, otherwise this ionization chamber will not work. This video is not about how to build an ionization chamber detector, so I won't dwell on it for too long. I just wanted to show that it is easily possible to build something more sensitive than the NukAlert, in a very short time, and with relative ease. The only slightly inventive step in this particular variation is using an SMA connector for the pickup wire lead through. The Teflon insulator is ideal for this application, and because the copper wire is the same size as the SMA pin, the probe wires can be easily interchanged. This isn't exactly the most beautiful thing we have ever made on this channel, and it certainly isn't the most functional either, but it does sort of work. Here we are testing with an americium-241 source, which is an alpha emitter. Alpha particles only have a range of about 3 centimeters in air, so it needs to be held close to the detector. And I am also testing this with the new soft X-ray source. At a similar range as we tested the NukAlert, the reaction time is actually faster on this homemade abomination. And here, testing it about 30 centimeters away from the source, the ionization chamber responds to this radiation, but the NukAlert doesn't. So, let's try at a really long range, in this case about 4 meters away. This result was really surprising to us. We genuinely didn't expect this tin can detector to have this sort of level of sensitivity. Anyway, here is the schematic. I'm sure some smart people will be able to improve on this, and share with everyone in the comments. Even though this product has little practical function, other than checking that X-ray machines are functioning correctly. Do we think that this product is a deliberate scam? Well, maybe. But it's not so clear-cut. We think that the creator of this product, Mr. Philip Smith, went into this project with an interesting idea, and probably good intentions. But once it came to marketing and selling this device, then the truth started to get massaged. In fact, in this case, the truth got a special massage, with a happy ending. Well, happy for Mr. Smith, because it is the NukAlert customers who are actually getting screwed. If you are one of those people that purchased this product, I know it is natural to be defensive, but there really is no need. This is a very cool looking product, which has a very strong marketing story. There is no shame from having been tricked by a convincing sales pitch, particularly one that weaponizes your natural desire to protect your family. So, you could always just add this thing to the collection of shit that goes into a hall of shame. It is often helpful to keep these useless things close, and to take a look at them before buying something else, just because it looks cool. Just chalk it up to experience and move on. And you can also thank your lucky stars that you were not born dumb enough to make weapons-grade purchasing mistakes. So, why not just buy a cheap Geiger counter instead? For the cost of the NukAlert, you could buy something like this FS5000 for the whole family. And still have enough change to indulge in a guilty pleasure, like a feast of Happy Meals and Big Macs. Looking at the schematic for this thing, it has that oversimplicity and lack of sophistication that I would expect from a student project. This is not what I expect from a commercial product that costs $180, and certainly not from one that is claiming to be able to save millions of lives. From public records, this appears to be the global headquarters for the company that makes the NukAlert. So, I am not terribly surprised about the poor quality of the design and manufacturing. And don't think that we have anything against cottage industries. On this channel, we have given very positive reviews of other homemade devices. What makes me suspicious is that on the back of this device, it has the certification logos for FCC and CE, but when we checked the databases for both of these product certification authorities, we didn't find any entries. The device also claims to have been tested for resistance to EMP, using a military test standard. We tried to reproduce this ourselves, but our equipment wasn't capable of delivering the required field strength. However, what really drove home the fact that this company is morally bankrupt, is that after the Fukushima disaster, this company went and produced special Japanese packaging for their product, and even increased the prices. At this time, the Japanese people had a genuine need for good quality radiation detection products, but that didn't seem to override Mr. Smith's requirement to turn a profit. The company did this, knowing full well that the product was totally useless for this application. And if the company, or Mr. Smith personally, wants to sue this channel for defamation, we wish them the very best of luck with such a pointless endeavor. Some of the regular viewers might be wondering where Max has got to. Don't worry, he will be back soon. He is taking a short break, he and his wife are expecting a little Maxine very soon. I wish him the very best of luck with that very important project. Anyway, that is all we have for you today. We hope you enjoyed our little video, or at least found some parts of it interesting. If you want to see more of this kind of video, you could always press the subscribe button. This is not a monetized channel, and we don't have any sponsors. So we can say what we want, and YouTube's algorithm can go and get f***ed. Thank you for your time.